present to you the first Beyond Spacetime seminar or talk of this semester, and it's twice as good as it normally is because we have two speakers today. The first one will be Lorenzo Lorenzetti, who is a PhD student at the University of Bristol, working with James Nagelian and Corinne Tepot. Lorenzo works on philosophy of physics, metaphysics of physics, and philosophy of science more generally, I suppose.
Yeah.
He's done an MA degree at the Università della Svizzera Italiana. I don't know what the really good translation of that name is into English because it sounds to me, University of Italian Switzerland is a strange way of translating that. Anyway, he did his MA in philosophy in Lugano there. Before, he was at the Vita Salute San Raffaele University in Milan, where he did his undergraduate in philosophy. Lorenzo has publications in top journals, several top journals, Philosophy of Science, Studies in the History and Philosophy of Science, Foundations of Physics, Synthese, top journal publications, very impressive. And we're very happy to have him here to talk today on two forms of functional reductionism in physics. Please, Lorenzo.
Yeah, thanks a lot, and thanks everyone for coming. So since I don't have much time, my main aim for today will be mainly to present the main ideas of this project of mine on functional reductionism in physics. So let's get started. So, I mean, I will go quite quickly on the more introductory stuff, since I guess most of you are quite familiar with the topic. So just to give very brief representation, the focus is on functional reductionism in physics. The idea comes actually from philosophy of mind originally, where the idea is to reduce phenomenal states like pain to brain states in this functionalist way. So we basically just functionally characterize states like pain in terms of their functional roles. And then we show how brain states can play those roles. And so we can functionally reduce mental states to brain states in this way. And the view has been applied to the philosophy of physics as well from many points of views. And as you are probably very much well aware with this, the main area, I guess, of application of this kind of view is the literature on space-time functionalism, where we functionally reduce space-time to quantum gravity, but the view has been also applied to cases like the reduction of thermodynamic entropy, or in the context of wave functional realism, to provide a realist account of three-dimensional entities in a functional reductionist way. And the main question I'm interested in is the question of the formulation of the view. So how should we formulate this view of functional reductionists in physics? And I think this is kind of an important question, as it has some quite important implications, especially connected with the ontological implications of the view. And it should be also made clear, I think, what's the relation between this kind of functionalist reductionist approach to other kind of reduction in science in general. So this is the outline. I will firstly start with an example, which is the functional reductionist account posed by Katie Robertson about thermodynamic entropy. And then I will present the two main, these two frameworks. So the first one is just the Lewisian functionalist framework, basically, which I call here syntactic functional reductionism to distinguish it from the kind of framework I'm trying to propose, which is called semantic functional reductionism. Okay, so let's start with the example. So here my case study is taken from this literature on the reduction of thermodynamics to statistical mechanics. And the aim of Robertson is basically to reduce thermodynamic entropy to some statistical mechanical entropy in a way to reduce the second law of thermodynamics. And I'm not properly going to defend this. I'm just going to assume this is kind of sensible and that like this approach is working, and I'm trying more to like make sense of this approach. So the first step of the functional reductionist approach in this case is to functionally characterize thermodynamic entropy. So we basically say that being thermodynamic entropy is to play a certain role. And the second step is to find a statistical mechanical realizer for this role. So this is done in a technically more conspicuous way, in this way by Robertson. Here I'm just basically reporting the result of her paper. Basically, the first step is the function characterization of thermodynamic entropy is carried out by defining these kind of equations that define the role of thermodynamic entropy. So basically, the idea is that thermodynamic entropy is that function that, according to equation 1, is constant in quasi-static reversible processes, and on the other hand is non-decreasing in non-quasi-static thermodynamic processes. So in a way, 1 and 3 characterize thermodynamic entropy as a function in thermodynamics. And yeah, the second step, so then the idea of function reduction is to find a statistical mechanical realizer for these roles of thermodynamic entropy. And the second step is carried out by showing how, by turning to Gibbsian entropy, we can show how Gibbsian entropy is constant in quasi-static processes and non-decreasing non-quasi-static adiabatic processes. So the idea is that in this way we can show, at least prima facie, that there is some important structural similarities between the roles played by the two functions in the two theories. And furthermore, she also points out that in the right parameter regime, we can show that the two quantities evolve in a very similar way, according to very structurally similar equations. So the conclusion is that we can say that thermodynamic entropy can be functionally reduced to Gibbsian entropy, and so in a way we can reductively explain thermodynamic behavior from statistical mechanics. And so this is a working example and like a real case scenario in which function reduction delivers an account of reduction. So yeah, as I said, my question is how should we formalize this approach? How should we try to like think about a more general framework in which this approach can be formulated in? And the traditional, and basically the only kind of approach that's available in the literature is the one by David Lewis, which has been defended also by Jeremy Butterfield and Rick Gomez recently, and has been also defended by other authors working in the literature. So I will just go quite quickly here, as it's quite technical, and I guess most of you will be more or less familiar with this kind of idea. So basically, the idea of the Lewisian approach is to formulate the first step, so the functional definition of the top-level theoretical terms in this way. So we build functional definition in terms of explicit definitions of the theoretical terms tau1 to tau-n in the first theory, which we want to reduce via the Ramsey sentence of the theory. And basically, this just amounts to the fact that in this context, tau I is defined as that thing that occupies the xy role within the theory, and this role is expressed in terms of the Ramsey sentence of the theory. And then secondly, the second step is carried out in this way. So we turn to a second theory, T star, which arguably can derive T, so the original theory. And we find a new set of theoretical terms introduced by the theory, so rho 1 to rho n, that arguably occupy the same role of the tau1 to tau-n. And we, again, functionally define these terms in terms of the role they play. So the rho 1 to the rho n are the occupiers of certain roles. And this is basically just like a formal way to characterize what is done in the first and the second step of the function reductionist account. And it's basically what has been like a way to reformulate what Robertson does in the paper. And this account also has like a third step, which follows from the first two, which is that we notice that from these two steps, we can logically derive theoretical identifications across the theories between the terms as they play the same role, and they have been defined in terms of their role. And in this framework, these kind of identifications play the role of Nagelian bridge laws in the derivation of T from T star. So here I would just want to wrap up the main features of the account. So this framework is basically just a kind of Nagelian reduction, since in this framework we have derivation of laws of the reduced theory from the reduced theory plus bridge laws, just as in Nagelian reduction. But in a way, it's also like a special version of Nagelian reduction, since the bridge laws are function derived. and not postulated, and they are functionally derived via the process I've shown in the previous slide. Another aspect of the view, which is, I guess, is a bit more like controversial in a way, it's that the view is arguably formulated within the syntactic view of theories, at least in an important way. That is, in this case, theories and functional rules are expressed by a Ramsey sentence, which is, of course, something which builds from the logical translation of the theory into second-order logic, and also the kind of view of functional action this framework appears to is related to a concept of reduction as logical deduction. So these two aspects, the use of Ramsey sentences and reduction as logical deduction, are arguably part of this, broadly this concept of syntactic view of theories. And finally, another aspect of the framework is that we have at the theoretical level type identity relations. This just follows from this is just the third step in the previous slide, since we are basically just by showing that the terms play the same role, we are identifying the roles. And if we are scientific realists, and I mean Lewis and people working on this usually interpret the view in this way, we simply read the ontological implications of the account of reduction from the reduction at the theoretical level. It follows that we can actually see how the theoretical identifications imply ontological identifications. So if we think that the theoretical term in the top level theory we have function defined denotes a real entity in the world, and we show that another entity plays the same role, we can say that they are the same thing also in an ontological sense. And this is a kind of conclusion that's embraced by Lewis and by most of the people usually. And yeah, so this is basically just these are basically the main features of the framework I want to focus on, and especially want to suggest that this kind of framework has some possible drawbacks, which are not, I don't think they should be seen as like knockdown objections to the account, but more like as possible difficulties that the account has to address. So one drawback is that the way this account works is that firstly, we have to translate whole theories from math to logic, at least in the original version of the framework. And from that, we can build the Ramsey sentence. And I guess I would suggest that this is not really a challenging and complex task, which I guess is something everybody is like can grant, but also possibly it could possibly be complex in a avoidable way, in a futile way, in the sense that if we find a way to build a functional reductionist framework which doesn't require all these steps, that will be preferable in a way. Secondly, and actually don't have time to focus on this here, and just pointing this out because some authors have focused on this aspect. In general, when we talk about reduction and functional reduction, we are not able to recover exactly the top level theories, the top level theory and the top level functional roles from the bottom level, because the top level theory is going to be actually corrected in a way. And we have seen this when I showed how the quantities behave in thermodynamics and statistical mechanics. So they didn't actually have the same theoretical role. They have approximately the same role. And some authors have stressed that this can be kind of a problem for an approach which adopts a syntactic-based account of theories, because we would have to construct approximations in a syntactic-based form rather than appealing to mathematical ones. And finally, and this is something which basically was implicit in the last slide, a possible drawback is that the consequence that the view taken literally implies type identities can be seen as a drawback, in the sense that the view has too much of a strict view on interlevel relations, since we would be committed to type identities between different entities at different levels. And the kind of possible conundrums that this feature can prompt can be easily seen in this case, because in this case, in the case of thermodynamic entropy in our case study, basically entails that we have to identify a property of an individual system, which is thermodynamic entropy, with a property of an ensemble, which is the Gibbsian entropy. And arguably, the second kind of property looks more like a construct than a real physical property. And also, it's not very much clear how a single property of a single system can be identical to a property of an ensemble as well. So I guess this is another possible drawback on the ontological side. Okay, so having presented basically the only kind of framework available and the possible drawbacks of the framework, I want to turn to the kind of framework I want to propose, which is this semantic functional reductionist framework. And the starting point of this approach is to embrace the semantic view of theories and the structuralist conception of reduction, as opposed to the syntactic view and to Nagelian reduction. And I will say in a moment what I mean by these two terms. I mean what I'm committed to in a way. But the very basic idea is that the semantic view is a model-based stance on theories. So it's math first, using David Wallace's terminology, as opposed to language first in a way. And the structuralist conception of reduction argues that reduction is a relation between models rather than a logical derivation between laws of theories. So just to make clear in which way I'm thinking about these two notions, I just want to quote a couple of people here, and yeah, to make clear in which sense I'm appealing to the semantic view. So yeah, here we have a quote by Lederman and Ross on scientific theories, and basically they argue just like in a way which is very much similar to how Patrick Sapis thinks about theories. They argue that the appropriate tool for representation of a scientific theories is mathematics rather than meta-mathematics in a way. And also they argue that the relationships between successive theories and theories at different scales are often limiting relations and similarities of mathematical structure. So roughly like morphism or maps between models rather than logical relations between proposition. So I guess this basically sums up what I'm committed to when I talk about the semantic view of theories. So I know that like the view is like the notion of the view can be quite controversial, and it can be quite controversial. How should we draw the line between the semantic and the syntactic view? But this is basically just this broad approach is basically what I'm meaning. And yeah, secondly, so just to deepen a bit the notion of structuralist reduction that's mentioned in Lederman and Ross quotes. I'm just quoting here Joshua Rosaler on structuralist reduction, just to make a bit more clear what I'm thinking about here by saying that reduction is a relation between models. So the rough idea is that instead of thinking about derivation of laws, reduction should be focused on showing how any real behavior that's represented by a high-level description can be represented more accurately and in at least as much detail by a lower-level description. And this is understood in terms of models. So the idea is that reduction between theories should be understood in terms of reduction between models, and reduction of the models of a high-level theory to model of the lower-level theory described in the same physical system basically just requires that the lower-level models successfully track all the features of the system that are accurately described by the higher-level model, at least as closely as AIMH does. So yeah, this is basically what I'm thinking about when I talk about structural reduction. So this is like a mathematical relation between models and different theories, and it's concerned with showing how models track features. Okay, so I hope this wasn't too quick. I mean, just to show you how I'm building on these notions to define a new framework on functional reduction. The notion of functional reduction I want to propose here is basically one that takes basically at face value the kind of functional reduction which is implicit, which is applied in the case studies like the thermodynamics one. So instead of talking about functional definitions, terms of Francis sentences, and so on, I think we can roughly see functional reduction simply as concerning showing how lower level mathematical quantities can approximately play the same theoretical roles, that is roles in the models for upper level mathematical quantities in upper level models. So the idea is basically that this view is a functional reductionist strategy that's not concerned with logical translations or anything like that, but rather it appeals to the semantic view in the sense that it focuses on models, and the key aspect of the view here is that functional roles are not logically formulated by Ramsey sentences, but rather they are mathematically expressed as roles within the models. So like we are taking to characterize the functional quantity, to functionally characterize the quantities we want to functionally reduce, we just focus on the mathematical quantities, and their roles is just the role they have in the equations, so in the models. And in this sense, this is like a semantic approach because it's math first, in the sense that it doesn't require any translation to logic. Also, we don't need to consider like translations of whole theories into logic to build Ramsey sentences and so on, but rather this can be arguably just a local approach. We're just concerned with the roles in the models of specific quantities. And finally, concerning the approximations issue, we can just use mathematical approximations directly rather than having to deal about like possible problems related to the syntactic-based kind of approximations. And yeah, in a sense, this is also a structural kind of reduction rather than a Nagelian one, because here we are just concerned with relations between models, like morphism or maps between models. So yeah, so in this sense, the view builds on the semantic view and on the structuralist view, and so it's quite clearly different from the Lewisian framework in some important senses. And yeah, as a final point, this kind of view, I think this allows for a more flexible approach to ontology in general, since differently from the kind of Lewisian framework, different from the kind of ontological commitments the Lewisian framework suggests, which I mean is related to also Aquinan approach to ontology, I guess. In this case, we don't have any direct correspondence between theoretical terms and entities, especially because models merely represent the world. And this is kind of tricky, I guess. If you're interested, I guess this is much more clear in the draft you can find on the archive. But basically, the idea is that in the Lewisian framework, since we are dealing with functional characterization of predicates in second-order logic, we can easily, like the natural approach is to take a Aquinan approach and read the ontological implications from that by drawing a one-to-one map between predicates in logic and the world and physical properties. In this sense, we are just talking about physical quantities in models. And so when we show that one quantity plays the same role of the other quantity, we're just talking about mappings between models, and the ontological implications remain like as an extra step, which is much more open in the sense that models represent the world and that they are not like related to the world in the same way the Lewisian account is suggesting. So in this way, we don't have to embrace type identities by necessity. We can of course do that, but that remains open, I think. So just to wrap up, the virtues of doing this kind of presenting this kind of framework is that without an alternative like the semantic framework, the only choice is to interpret Robertson case study by Lewis. But I argue that the view imposes the burden of logical translations, and there are some possible logical, ontological conundrums coming out of that. And so the idea is that the semantic framework takes case studies like Robertson one at face value. So functional rules are expressed by the equations. Functional reduction is a relation between the quantities. There is no forced ontological identifications on this respect. So this is the last slide. Just summing up here the main features of the two accounts. And I will just conclude with a disclaimer, which is that I don't want to argue here that the distinction between these two accounts is like a clear-cut kind of distinction. It's probably much more a matter of degree, and possibly it's also like a pragmatic distinction. Indeed, like the way I began to think about semantic function action was because a lot of people were like uneasy with the idea of buying into the whole division framework. So the idea was to build like a more minimal kind of account. But the way in which the syntactic and the semantic view are can be distinguished is like a very difficult topic. Like, and there is and possibly there are more subtleties than the one I presented here. So this, I think, it should be viewed more as like as a pragmatic distinction in a way. And I think like there is room for some possible kind of synthesis between the two. So in a way, like by presenting this alternative framework, I guess I'm also wanting to stress the drawbacks of the syntactic function reductionist view, and possibly like after having presented the alternative, we can possibly turn again to the first reason syntactic function reductionist framework and modify it in a way such that we can like accommodate some of the features of the semantic view without buying into the whole second account. So yeah, I guess like there is much more room for discussion. And yeah, that's all. Thanks.
Thank you very much. Questions, comments, please?
Thank you very much.
Or should I just unplug it?
Oh, you should use this as a microphone, this one.
Yeah, okay. What do you mean?
Just move this thing.
Okay.
You send it to Baptiste.
Because otherwise the people in the recording can't see, right?
Thank you. Just to get a better idea of what you're after with the semantic reduction. So the reduction is between models and models. But because according to the semantic view, right, a theory is a collection of models, right? So do you think of the reduction as a many-to-many relation? Or do you have a relation between one model corresponding to theory one and another model corresponding to theory two? Or is it more like a systematic mapping between the spaces of solutions? Or do you have any more ideas about how this works? I was a bit unclear what you had in mind.
Yeah, thanks. So yeah, I guess this is like an important question. So the way I presented this was quite sketchy in a way. I mean, like kind of broadly formulated. So probably like the second kind of view you had in mind, like I'm not like trying to argue that this like a one-to-one mapping between single models. It's just like more like mathematical mappings between like the set of models describing the top level quantity and the set of models describing the lower level quantity. So yeah, I don't know if this kind of replies to your question.
Niels?
Thank you. Yeah. Yeah, so a question about, I'm not eating it now. A question about the syntactic semantic distinction. So I personally always have a quite loose reading of it. So in terms of physical theories, yeah, the equation of motion basically give you the syntactic view and the solutions semantic view. And so for me, so to speak, this question about syntactic versus semantic is independent of this question of logic versus mathematical. And I'm just wondering, where I'm going wrong here. Yeah, could you just comment more on this?
Okay, yeah, I guess like, yeah, as I was mentioning, I guess like this is like a hugely controversial part of the whole project, in the sense that there are many ways to define the syntactic view and many ways of defining the semantic view. I think like in a sense, like the idea of taking theories as like collections of propositions, in a way, this seems to be like kind of core aspect of the syntactic view. On the other hand, I guess it's less clear what the semantic view implies. So what I'm thinking about here, like the kind of distinction I have in mind, is I guess more akin to what David Wallace is arguing when he distinguishes between math first and language first. So like I guess the point is more, yeah, I guess like the important line I want to draw is between a kind of logical and language first view of theories, in which like yeah, I guess like the real important point here of the application of the syntactic view is that the functional roles have to be defined, are defined in terms of logical roles, like, I mean, in terms of the Ramsey sentence. So the kind of network of relations is described by logic in that sense. So it's only derivative on the mathematics. And basically what I'm committed to when I talk about the semantic view is just the fact that we shouldn't do this step of translating theories to logic, or in general to think about theories as proposition. We should just take the math at face value. So like I guess you can think about the two views in like in a contrast in this way. So like the second one is less committing, you know, in a way.
Yes.
I mean, when I look at the literature, for instance, papers by Lutz about how the syntactic view is equivalent to the semantic view, then that's someone who clearly works just in the logical regime, right? So this would all go basically as syntactical for you anyway, right? Is this kind of correct? I mean, so after all, the distinction is more about math versus logic, or
yeah,
yeah.
So yeah, and I know that right. I know that paper by Lutz. And yes, as I was saying, like I think that kind of debate, and the arguments from people saying that the semantic and the syntactic view are not that much different. That's exactly why, like, I wanted to stress this last point about the distinction being more pragmatic. So maybe like using the term semantic it can be kind of tricky and misguiding in a way. But yeah, like, so yeah, I don't want to, yeah, as I was saying, I don't think I need to buy into like a strong distinction between the views. If it still makes sense to distinguish between functional roles as derived from Ramsey sentences and functional roles just in terms of the mathematical roles in the models. Yeah, and like in a way also this comes from the fact that like people working on this usually like, yeah, there is like some skepticism by a lot of people on the logical translation part, and like it seems just more useful to think about the mathematical roles in a way. It's just more simple and straightforward. Thank you.
Oh, thank you, Lorenzo. It's great to have you back. This is actually goes in your direction, and you know that you thought about it a little bit because of your thesis. So here's one way in which you can push a little bit more why the syntactic, at least the original one, right, sometimes cannot work. Because as it works for Lewis, because Lewis was independently committed to an identity theory of mind. He thought he had independent reasons for that. Now, every time you think that the functional reduction should track robust relations of relative fundamentality between the terms, like for my guess that these guys want space-time to be, you know, related somehow to something more fundamental than, or surely the way functional realists wants to say that if there is a table, you know, there's going to be the wave function has this shape. They shouldn't type identity exactly because they really want that to track relative fundamentality relation out there in the world. So type identity will never give you that. And that's true. Now, so this goes all in your direction, right? Because maybe you can do it in your framework. I don't know. So, but now we have also other though logical tools, right, to get these productive relations out of identity statements, for example, generalized identity statements and so on and so forth. So there might be a view that gives you that. Now, I don't know how to do it, but I have the telephone number of Fabrice, if you want. So to say, for example, for a system to have the thermodynamic entropy is for it to have the Gibbsian entropy. And that's a different identity statement. And now, I mean, some of the criticism that you have will go through, but it seems to me that the relative fundamentality things, at least for wave function realism and space-time functionalism, is really important, right? And that's why Lewis was super happy with this, right? He was independently committed to, you know, the mind is the brain. You stop asking me that, like the mind is the brain. Yeah.
So, like also we can do this also in the syntactic framework in a way, just by yeah,
like
yeah.
tweak it a little bit, then it will be better. Seems to me.
Yeah, okay.
Unless you have a more pressing objection to the syntactic framework, it cannot work in this case. These guys are very interested. I mean, I guess that you guys are interested in it, saying that it's more fundamental, right? Really more fundamental, not just a more fundamental description.
Yeah,
it's really more fundamental stuff.
Yeah,
which seems, I mean, type identity cannot agree with that.
Yeah. Okay, but like this, the kind of the framework you are like suggesting, does it like address this kind of asymmetry? Or we should still think about this?
That is going to be more fundamental than one.
Okay, I see. Yeah. Okay, well, that seems like a good suggestion. We'll think about that. Yeah, thanks.
You mean more fundamental in the sense that you kind of had the distinction between more or less kind of complete descriptions, something like that?
I mean, these people have a way more robust definition than that. They think that there's going to be a relation of determination between the two, and this trucks also explanation. So the thermodynamic, in the case of Robertson, for example, they would say that thermodynamic thing is somehow determined by the Gibbsian entropy.
Okay, I'd be happy with the more or less kind of complete descriptions kind of thing. And maybe you would too. I don't know.
Yeah.
That wasn't actually my question. It was sort of fortuitous that it came there. I just wanted to ask about, you know, on the right column, the connect, you know, how tight is the connection between semantic and structural there? Because it doesn't quite seem that structural necessarily follows from the fact that we've gone semantic, right? I mean, I think of structural, you know, I mean, crudely, you could think of it as, well, what matters, the relations or the kind of the relator, and one could have relation, you know, relator forward, forward correspondences between models. So could you have sort of a non-structural semantic functional reduction? I mean, maybe it wouldn't actually occur. And so that's just a way of getting at the question. As soon as I say semantic, do you think we're already saying structural?
Okay, I mean, that's interesting. So, yeah. So I think you can definitely like translate in a way this structural approach to the syntactic account. So in a way, like this is not like necessarily tied to the semantic view. However, I'm not sure like if you can have like the semantic view without some kind of structural account. That seems like part of the whole idea of the semantic view as like concerning theories in terms of family of models. Like, I mean, like the word structural maybe here is a bit unfortunate as it carries a lot of meaning from the literature on structuralism. But I guess like this was present from from like the 60s when Sapis was working on these. And like it's called structural just because reduction is concerned with mathematical structural relations between models. So yeah, I'm not sure if we can like still, I mean, Yeah, I'm not sure how you could like
structure in the sense of ontic structural realism.
Yeah.
You don't mean anything.
Yeah, I don't.
Was that?
Yeah, that's right. Yeah, I don't mean that. But it's just like yeah, I guess like I should maybe use another term, even though this one was the one used in the literature. But yeah, like I'm not buying anything as strong as that.
Right. I mean, some
But
of
yeah,
you said like think, well, we should be using category theory here, or
Yeah.
something to make this out, and then you seem like we're in some OSR kind of
yeah.
story. But you don't quite mean that. Yes.
Yeah, no, that's right. But yeah, anyway, I think like in general we can like, I don't think like this, the distinction like between these features is like really that much clear cut. We can actually combine the two views in a way like we can combine different aspects. Like I don't think the syntactic view is by necessity global, can be also local in a way. And yeah, maybe there is a way to combine semantic view with some kind of non-structural account of reduction as well. I guess I will have to think about that.
Well, this was interesting. Thank you so much for the talk. My question is actually out of curiosity whether you've come across Hans Halvorson's argument in his book, The Logic of Philosophy of Science, where he says that actually the semantic view of theories, and especially an account of functional reductionism in terms of relations between theories like symmetries, isomorphisms, smuggles in the syntactic apparatus of a meta language, and therefore you can't actually get around that. And I was wondering if you've thought about this and what your response would be.
Yeah, I guess I don't have like an answer which is very much different from what I said about like to Niels about Lutz's work on distinction between semantic and syntactic. I think like in a way I agree with the fact that if we look more into the semantic view and we realize that like the kind of models they are thinking about can be like translated into category theory type theory or something like that, in a way we are talking about like a meta language, like a meta mathematical language of some sort. And that's basically why like I wanted to be committed just to a notion of semantic as mathematically formulated and not like as committed to any specific view on the meta mathematical part of theories. So yeah, that's the kind of sense in which I was thinking about semantic functional reductionist framework. But yeah, like I grant that it's possible that looking more into this, maybe I realized that there is not enough difference, like there's not much difference between the semantic and the syntactic view on this aspect of models. So that could be a difference in that sense. But yeah, like as I said earlier, I still think that there's like a pragmatic distinction, and also like there's kind of a distinction between the idea of reduction you are buying into, especially since like even if there is like meta mathematical part of the like the meta mathematical side of the semantic view, still I think like that can be detachable from the Nagelian picture of the reduction, and is still closer to a kind of structural kind of reduction, even if we are talking about models in a way which resembles a syntactic view. So yeah, I don't know if this.
Can you please then just walk a little slower in what the pragmatic distinction is? Because from what I understood, you would need a meta language, and it can take whatever form you'd like, whether logic or mathematics, but you need a meta language to even compare models. And to me, it seems like some of the difficulties that you would then inherit from a language first approach from the syntactic view would also be imported into the semantic view of functionalist reductionism. And I'm wondering how you can avoid, what the pragmatic distinction is that you can avoid importing those difficulties.
Yeah, so like I guess, like if I just go back to the kind of drawbacks of the syntactic syntactic kind of functional reduction. Like, I mean, so in a way, like the first difficulty, the translation of theories from math to logic, that kind of difficulty, I guess it arises in any case in the syntactic kind of framework. And yeah, it's possible then if we look more closely on how the semantic function reductionist framework works in detail, maybe like there is going to be some problem related to translations as well. But yeah, so this is something like, I guess this is like the main part of the account I have to think more about. In a way, like the last point still, I think this is going to be different in any case, I mean, prima facie, just because we are talking about models and we are not going to be committed to this kind of Quinean approach to theoretical identifications. Like there is no clear cut, like there is no clear and direct ontological implication from the theory to the ontology. Since we are talking about models, and I guess that's going to be true in any case, like in any way we are talking about models. But yeah, thanks.
Okay, I'm afraid we have reached the end of the discussions of this journal.